begin.
We need beans.
What beans?
Soybeans and mung beans.
Can't you use other beans?
No, soybeans and mung beans are very nutritious. Did you know soybeans prevent chronic diseases and are rich in vitamins and minerals? Mung beans contain several essential vitamins, are high in fibers and amino acids too. That's why I need them. I cook must be nutritious.
So, out of curiosity, what do you do with them?
Well, with mung beans, you can make all sorts of herbal cereal and Indian cuisine. Soybeans can be made into soy milk and pastries. Just so you know, soy milk is a healthier alternative as compared to fresh milk.
Wait, but do people like these days?
Of course, the demand for soybeans are higher as sales increases over time. Fermented soybeans are also healthy as it is said to reduce the majority of soy content, while making the beneficial nutrients available to the body. Thus, people who like to be healthy or in a mental illness can use soy milk or soy-related products to help them get over it. It is the same for mung beans, and mung beans have many herbal properties that can help revitalize the human soul.
Well, sorry, but the demand for them is too high, and I have trouble coping with the demand. If I water them with too little water, they will shrivel and die. But if I water them with too much water, mold will grow on them, and they can't grow properly. And restaurants and supermarkets send in large orders of them, so I have trouble coping with the demand.
If only there was a way for you to grow your beans faster.
Actually, there is.
Where do you come from?
With the recent advancements in soil pH measuring systems, a lot more farmers are beginning to alter the pH value of their soil in order to allow for their plants to grow better.
So, pH. I heard some of my farm friends use that to make their beans grow better, but not all of them are effective.
That's because they may be using the wrong methods of soil pH to actually alter the pH balance of the soil. The experiment that my team has done has shown to prove that this theory is right. We tested the soil pH on different plants such as mung beans and soybeans to see whether they will actually go better or worse.
Excuse me? Your experiment? Where did you come from?
Done by our experiment.
He's right though. The experiment has found results proving that altered soil pH benefits the plant. Wait, so exactly is the soil pH from?
Soil pH is essentially the pH value of the soil. It means the potential of hydrogen. It determines whether the soil will be acidic or basic.
The chemicals help the plant. This is due to certain nutrients that can be found in abundance in an acidic environment, such as micronutrients like copper, chloride, iron, and much more. So of course these actually allow the plant to grow better. My statistics can prove it. Well, just so you know, us farmers don't find the height of the plant very useful. You may be able to allow the plant to grow tall and strong, but it is not nutritious. It doesn't taste good. It's useless.
Well, for the experiment,
We use a method of plant to determine how well it has grown. This way we know that the plant would have its nutrients. Therefore, the value of the plant is the pH value of the soil is our dependent variable. The dependent variable means the growth of the plant, which we can judge by the plant's mass. Our independent variables would be the pH value of the soil. That's the one we're testing for. And for our constants, there are things such as location, type of soil, type of need. My statistics can prove it.
You keep referring to your statistics, but I don't see any numbers on paper.
Shall I accept that? Here are my statistics.
okay, so the first graph we have is a scatter graph of the growth of our mung beans. As you can see, the highest point over here determines which bean can actually grow the most throughout our experiment. It belongs to the soil pH of 5.4.
And from the graph, you can also see that the plants in the neutral or control soil grow much less than the plants which grow in the acidic or wet soil. Furthermore, the point is also significantly higher as compared to those beans which would grow in the basic soil. You can see that the mung beans in the acidic soil has grown by 2 grams more than the basic soil and 4.17 grams more than the basic soil. As it grows better towards the acidic side, it is definitely the better choice.
So basically, mung beans grow much better in acidic soil, as you can see from the graph. This is important. Remember that we use aluminum sulfate to alter the pH of the plant, as the chemical also actually helps to benefit the growth of the plant. In this case, we have aluminum and sulfur in the soil to actually help the plant grow much better, and therefore the chemicals that we use to alter the pH of the soil also contributed to the amazing growth of the plant.
What about soybeans? And here we have our soybean scatter graph. Once again, you can see which points are higher than the others. Wait, why are there 2 points for each plant in the altered soil? That's because we had two recordings for the soybean plant. The purple cross represents the first recording and the brown circle represents the second recording.
Wait, but the weight of the plant with a soil pH of 5 increases.
Sometimes the acid in the soil may be actually too strong for the plant and actually start to corrode or harm the plant instead. Because of this, the plant will actually wither and die. At least from here, we can actually tell that the soil pH of 5 harms the plant and makes them wither and die. So that way we know that we shouldn't put too much chemical agent in the soil to make the plant die.
We actually used ammonium sulfate to increase the basicity of the soil. The pH levels vary from 7.2 all the way until 8.4. You see, the plants don't grow as well in these environments. In these soils, due to lack of micronutrients, which tends to be less available in soils with a higher pH.
But we're not done. Here's our third graph showing the growth of our soybeans.
This graph is different. It's a bar graph of how well the beans have grown throughout the entire experiment.
From this graph, we can see how much the bean grows over time. The first darker shade of the bar represents the first recording as the purple cross did, and the second represents the second recording. From this, we can also see the overtime effects of acidic or basic soil. Even though we pointed out that the soil pH of 5.4 was the best out of all of these, it might not have grown as much as the others from the first recording, but it made up for it in the second recording.
Wow, so you have considered long-term effects on the acidic soil. I'm very impressed.
That's right. Once again, the bean grows better in the soil pH of 5.4, having shown to significantly grow better as compared to the ones which are grown in the neutral soil.
So how does this help my situation?
Well, with this information, we can revolutionize agriculture. No longer do we have to wait for our beans to grow and see the not so delicious or nutritious fruits of our labor. Now, because of chemical alterations such as soil pH, we can actually allow the plant to grow better and have more nutrition in them.
Are you sure? I don't think all the trouble is worth it.
It definitely is. Though it may be troublesome to alter the pH at first. The results are
Completely and totally worth it. You do not have to wait so long for your beans to grow anymore, and no longer will you have irritating cooks behind your back trying to chase you for the beans.
Hey!
Is there something else I can do to improve the plant's growth?
Yes, changing the nitrogen, phosphorus, and potassium values of the soil also helps the plant to grow. This is known as NPK. You can also improve the growth by adding such things as fertilizers, as they speed up the rate at which acidity develops in the plant. Also, the decomposition of organic matter helps to speed up the growth of the plant because most soil bacteria prefer a slightly more acidic pH range. Therefore, if you actually have decomposing organisms such as worms or beetles or flies in your soil, it will actually help the overall well-being of the plant.
Wow, there are actually so many things to speed up and improve the growth of soybeans and mung beans.
And finally, you can thus see that the soil pH of 5.4 suits all of the following beans such as mung beans and soybeans.
Oh, so they really do go better than lower pH. What's the exact pH again?
5.4!
Micronutrients can be found in abundance in soils with a lower pH. These are the very nutrients which are essential to the well-being of the plants. Soils with a higher pH, the basic soils, are actually higher in macronutrients, hence compromising the amount of micronutrients in the soil available, which is why it may not have grown as well as compared to those which have grown in a higher pH.
Exactly, so as you can see from our experiment, the mung beans and soybeans grow best in a soil pH of 5.4. Also, the acidic environment allows for it to grow much better. And
Okay, thanks.
Do you have my beans?
No.
and
Okay, thank you.
Alright, thank you. They took about 8.5 minutes. We shall open the question to the floor. Kaylen first.
How does this help me if I don't plant soybeans? I don't plant my mung beans. I'm not a farmer. How does this help me?
how does rocket rockets help me if I'm not a person who wants to
Can you not
Just the English
just answer the question?
Okay, as each experiment has their own target audience. For us, our target audience happens to be farmers and people working in agriculture, or such as cooks like Jemima or farmers like Carver. We not necessarily have to target at the entire human population in the world, but we actually want to speed up the growth and actually improve the beans because right now we're running out of land in this world, and this kind of soil pH measuring systems can also help to make the plants grow much faster, and then we'll have food and not will starve to death.
Okay, Jerome next, okay? Jerome. Then followed by Enoch.
Why did you choose to test on soybeans instead of rice and other more important crops?
Oh, this has something to do with how fast these kind of plants can grow. We chose soybeans and mung beans mainly because they can germinate in less than a week, and also they can grow very fast. Our initial idea was to use rice, as everybody here eats rice because it's also a very, very common crop in Asia. However, rice takes 2 weeks to germinate, and then from there it takes 1 week to even grow like this high. So we chose to abandon the idea of rice and chose mung beans and soybeans as they had equal amount of benefits in their own nutrition as well.
Okay.
Yes, Celine.
Okay, Cindy.
I get it when you all say like mung beans and soybeans have nutritional value, right? But what if people don't even want to eat them? So what's the use?
I'm afraid that's a choice of personal preference.
Okay.
Changing the pH level of the soil will affect other organisms, including the plant. But if you have choose to lower the pH of it, and the soya bean has a lower pH compared to us, our body may not be able to digest it properly. Our ancestors need about a total of 2 to 3 pH level in order for it to be digested properly in our stomach. So changing the current pH of the soya pH, how are you so sure that the soya bean we eat will not cause us to have any stomach?
Okay, that's actually a very, very good point pointed out by science evidence. This kind of methods has actually already been carried out by farmers. So technically speaking, the food that we eat has been genetically modified to allow them to grow better or be able to withstand pesticides and can grow more so that farmers can harvest more. So technically speaking, your body's already handling all that extra pH and apparently we're all alive and well.
Unfortunately, when you genetically modify food, you actually add another strain of DNA inside now for it to grow faster and be more resistant. But unfortunately, you are changing the pH of the soil. Now, the pH in the plant is different, meaning that the seeds is so different. So I want to know the effect of what happens if you eat too acidic seeds, or should I say soya bean and mung beans.
That's the thing, we're not actually going, that's the soil, it's not the seed which is going to be the one eating it, because it's the plant which is growing in the acidic environment which makes it grow faster. It doesn't really affect the seeds because you need a different seed every time you plant, not from the same one, because we are actually eating the ones which we have grown. So you see, what you are actually worried about isn't actually a part of our experiment. You get what I mean?
So you are simply saying that the pH level of the soil will not affect the seed level.
It would affect it by making it grow faster, but it wouldn't affect it if you eat it. Any more questions?
Can I look at your graph again? You said about the 5.4 one. Okay, so maybe this time, those who have not answered the question, you can take my question. Hold on. Yours said 5.4 is the most optimum. What about 5.3, 5.2, 5.1? Have you all done any research on that?
That's actually the limit of our equipment. Though we have a lot of advanced equipment here at FSC, we didn't have the time nor the resources as well to actually test every single pH up to the smallest of a decimal point. So we decided to go in intervals of 0.2, and if you actually notice 0.4 or 0.2 is about 0.2.
I see 5.9, I see 5.
It differs.
It differs because sometimes, as Carmen's the one who actually had to stir all of those, she actually can feel the pain of
Who had to do?
Carmen.
Okay, Carmen.
So
Maybe Carmen, you can tell us more about the pH value. What happened to 5.2 or 5.0?
Because for this part, because it's harder to do like this whole part, because this part, right, for this chemical use is very hard. So we decided to use a difference of 0.2, and it doesn't affect much, but there's still a difference.
Yeah. So you are saying that 5.4 is the most optimum, but I'm saying my question is, what if 5.2 may be the most optimum, but you have not tried it out?
Oh, actually, I can answer that question. Actually, from our results, the reason that we didn't put 5.2 on this table is mainly because it had a negative weight. It harmed the plant so much that it actually went down from its initial weight. So in the end, we took it out. Okay, now an example is this. Is a negative.
Yeah. How do you calculate the negative?
Oh, sorry for everyone else's question. Do you want to explain?
Yeah,
Because
Jemima.
we weigh the soil before we put the plant in, then the weight of the soil is supposed to be 130 grams.
Yeah.
Sometimes the few plants that when we weighed the plant with the soil, it was like 120 something grams. So it was like a negative weight.
No, but you see, recording one is the original, right? The first weight that you take, right? How do you take negative weight?
We put the container on the weighing scale and it says 1 to something.
No, basically when we had a negative weight, because when we had the germinating bean, it's actually because how do I say, something about the soil actually kind of kills the beans inside. So it can't actually grow. So because of that, some of the water, which is good water, also kind of evaporates. So hence it actually includes it. So the negative weight is just the soil, not including anything else, because everything else is either dry or withered. So it's basically no more weight.
Okay.
You know, you said 5.4 is the optimal, right? But don't you think it's a bit of an anomaly? Why is it so high compared to the rest? I mean, you look at the rest of your graph, right? They're very, in fact, the highest is around 6.6 to around 5.9. Why would you say it's 5.4 is such an anomaly?
Firstly, ta-da! This is the effect, wonderful effect of self-page memory systems. Secondly, we actually screamed when we found out that with 71. We do agree that it may be a bit off, but actually it did grow the best. It didn't temper the results at all. So it just shows that upping the soil pH does help the plant to grow better by this much.
Okay, last question.
How do you, I have 2 questions. How do you actually change the pH level?
Use chemicals and then we, of the ammonium sulfate, right? Then we will add water, which is not the tap water on the labs because that the pH of that is really different. So we use the toilet water, the tap water to change the pH.
Isn't tap water pH of 7?
Yeah, but the science that pH is actually an acidic one, right?
Yeah, it's a different pH.
The water in the science is more acidic.
Okay.
So if you're trying to revolutionize the way of growing your mung beans, how much will it cost?
It's just purchasing chemicals, changing the pH, and just watering
All
it.
over the world.
Yeah. It's not just one person doing it like what we have here. It's actually a lot of farmers working together to change the soil
So you want the farmers to buy the things that sell the chemicals, which is very hard to get, which you can only get from labs.
Actually, it's not hard to get. We checked with the we actually checked with the labs, and they said that they actually got it quite easily, except for those rare chemicals that they have to import from other countries. The ones that we got are actually viable in Singapore.
Okay, I'm sorry I have to stop the presentation. Okay, Hao Xian, you can still ask them. I'm going to stop it because we crossed the time already.